Welcome to ClickMyProject.com. Now we are going to discuss about the project multi-class classification of plant leaf diseases using feature fusion of deep convolutional neural network and local binary pattern. Now we are going to discuss about the abstract of the process. Plant leaf diseases are one of the primary cause of decrease the agricultural production quality and then the quality of the overall agricultures. With ongoing the charges in the plant structure and then the conversion techniques, new diseases are constantly arising on plant leaves. Thus, accurate the classification and detection of the plant leaf diseases in their early stages will limit the spread of the infections and support the healthy development of the plant production systems. This process is proposed a novel lightweight deep neural network that is based on the convolutional neural network model for obtaining the high-level hidden feature representations. The deep features are then fused with the traditional handcrafted local binary pattern techniques features to capture the local textural informations from the plant leaf images. By combining these two features together, the sensitivity of the algorithm is more high and then the effectiveness of the process is more high when the stability of the features is more high. After doing the feature extraction, the classification is applied to classify whether the input image having the which kind of infections is there. Then finally the performance of the process will be evaluated by means of the accuracy. The overall process is done by using the plant leaf datasets which is taken from the plant village databases. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. This project consists the steps, that is the modules like the input image, pre-processing, segmentation, feature extraction, data splitting, classification, and finally performance estimation. At first, the input image is taken from the dataset. The dataset consists of a lot of input images which is having the several type of leaf diseases. After taking any one image from the dataset, the pre-processing will be carried out. In this pre-processing, the primary step of the pre-processing is the image resize, which means the number of row and column will be resized in the size of 224 x 224. After doing the image resize, the feature extractions will be carried out. Already we have discussed, we have two kinds of features which is based on the patterns as well as the deep neural network, that is the convolutional neural network. After doing the feature extraction, before that we have one step, that is the segmentation. The leaf regions will be segmented. Based on that segmentation result only, the features will be extracted by means of the two feature extraction method. After doing this one, the data splitting is carried out to split the data into two categories. One is the test feature and then the another one is the train feature. After splitting the data into one test and a train, we just move to the next stage of the project, that is the classification. In this classification, the machine learning is applied to classify whether the input image is healthy or unhealthy. In case of unhealthy, the name of the bacterial or NGO type is displayed there in the classification stage. After doing the classification, the performance estimation will be evaluated by means of the accuracy, sensitivity, and specificity. Here the accuracy is more important to classify the whether the performance of the classification is high or not. Now we are going to discuss about the running procedure of the process. At first, open the Spider 3.7. After opening the Spider 3.7, you have to change the current directory like this. After doing the changing, we have to open the main file.py. This is the executable file. After opening the main file.py, we have to click the button run. Once the run button was clicked, the dataset will be open. In that dataset, you can see the several options of the image. You can select any one category from the dataset. After doing the selection of the image from the dataset. The corresponding process will be done one by one, and those results are shown in this console window. You can see the every results in this console. At first, the original image is displayed, that is the original image means we have taken from the dataset. After doing the import the image, we just do the second stage of the project, that is the pre-processing. In this pre-processing, totally we have two stages. First stage is the image resize. The image dimension is resized into 224 cross 224. You can see the difference between this image and this image. The image size will be vary for row and column wise. After doing this one, the channel separation will be carried out. Input image having the three band, that is the red, green and blue. Here we have segregating the channel into one red channel separately, green channel separately and blue channel separately. After doing the channel separation, the grayscale conversion is carried out to convert the image RGB image into one grayscale image. After doing the grayscale conversion, we just do the segmentation by means of the thresholding and morphological. You can see the difference between the grayscale image and then the segmented image. In this segmented image, the background and foreground will be differentiated by means of the binary pixels. After doing the segmentation, the feature extraction will be carried out. In this feature extraction, the CNN and then the LBP is applied. These are the results for the CNN, and then the LBP results are displayed here. After doing the extraction of the features, we just shows the value of the feature which we have extracted. This is based on the pattern values we have extracted from the image. After doing the feature extraction based on the test feature and the train feature, we just do the calculation by means of the machine learning method. So the classified results will be displayed as a black spot. Hence I am imported the image as a black spot. Then the recognized results will be the black spot during the classification step. After doing this one, the accuracy of the image will be displayed here.